synthesis concept. Fine. When you remove a pole at origin, so what is meant by pole at origin? So we should have s equals to 0 as a pole in the function, right? Okay, let us say when z of s is having a pole at origin, then it can be written like this, where that means here s can be taken common from the denominator. Then what it means, you are having s equals to 0 as a pole, right? That is how it is chosen. So now the idea of synthesis is to separate the terms. Then how we can separate the terms? Maybe we can use partial fraction, let us say, one of the mathematical tool we have to separate the terms from a given composed function. So let us say we have k naught as residue at s equals to 0. Then we have another ratio which can be considered as z2 of s and k naught by s as z1 of s. Fine. So these kind of things we have seen in the concept of removal of pole at infinity. The same thing is applied here. So we got the separated terms from the given z of s, which are nothing but z1 of s and z2 of s, and they are added together. So again with the cross multiplication we can get k naught as a naught by b1, right, for the chosen coefficients. And here z1 of s is nothing but k naught by s. That means which component is that? Is that inductor or capacitor or resistor? It is not resistor, because resistance R is having no s involved in its impedance value as well as admittance value. So only inductors and capacitors are having s variable in it when we go for admittance or impedance. So then what is this k naught of s, k naught by s? It is representing the impedance of capacitor, because it is equated to the impedance value, not admittance. Then this becomes what it becomes? This becomes capacitance only. Okay, what is the value of capacitance? It is 1 by k naught, because the impedance of capacitor with a value of C is 1 by Cs. So when you compare with that, you will get it 1 by k naught. Perfect. Okay, that means we can separate capacitor out from total z of s, and the remaining function will be z2 of s. Okay, this is for z. What if this z is y? So if that z is y, then this C becomes inductor and it will be in parallel. So right, that's it, very simple. This is just mathematical manipulation. This is how we can simplify many things. Mathematics is a best tool for doing many things, right? That's it. This is about removal of pole at origin, right? Now we will see the removal of a constant. So if you see removal of a constant, which is very easy because there is no s variable involved in it. So let us say if a real number r1 is subtracted from z of s such that z2 of s is equal to z of s minus r1. That means suppose if we have a constant term separated out from the complete function, that means z of s is equal to z2 of s plus r1. That means r1 is considered as z1 of s. So then what is this R1? It is just a constant term. Which element can be represented with? It is nothing but a resistor, right? But in case of admittance, if admittance is given and there is a constant, that is going to become conductance, not resistance. So this is a simple logic. Just like capacitor and inductor dual nature, we have resistance as well as conductance dual nature. So if you know that, you can easily get it, right? So this is a simple one, not much complex, like removal of a pole at infinity or removal of a pole at 0, right? Okay, that's it for this lecture. Thank you.